Use the empirical rule to solve the problem here. The annual precipitation for one city is normally distributed, right? So it follows the normal distribution with a mean of 543 inches. The mean, right? So that straight away I'm going to write that down. Sigma, or not sigma, mu. This is mu, pronounced mu, Greek letter, and that's the shortcut for writing down mean, right? So mu equals 543 inches. And the standard deviation, we use this symbol here, sigma, equals 2.2 inches. And then we're asked to fill in the blanks. And 68% is a kind of a key thing here, right, to do with the empirical rule, which is a kind of a guideline to go by. The precipitation in this city is between something and something inches. Now, here is a website I like a lot. It's called Maths is Fun. And what we're looking at here is the empirical rule kind of laid out in sections. You see, this is a standard normal curve. And this curve has been adjusted, it's been standardized so that instead of having 543 inches as the mean, we have 0. And this is the standard or Z curve. But all normal curves follow this pattern whereby you see this 68% of the stuff, or 68% of the area falls between +1 standard deviation and -1 standard deviation. So between the mean plus or minus 1 standard deviation, we get 68% of the values. There it is in black and white. 68% of the values are within 1 standard deviation of the mean. And so on. That's the one that applies to our question here. You see here 95% of values are within 2 standard deviations of the mean. So how does that work? How does that work for our question? I'll just move this back out of the way. And in our question here, we don't have a standardized curve, but we still have a normal curve, right? And this is very rough drawn, but anyway, our mean here is 543. And +1 standard deviation for us is going to be 2.2 inches added on to this guy. This is going to be plus sigma, right? And this is going to be minus sigma. This is a distance that away from the mean value. So it's going to be, in one case, it's going to be 543 plus 2.2. That'll give us this value here. And the negative sigma here is going to be 543 minus 2.2. And with that set up, this area between those two cut-off points, between here and here, would be 68% of the years. So 543, take away 2.2. What does that give us? 540.8. Is that right? 540.8 plus 2 would be 542.8, and the 2, yeah. So that's going to be 540.8 inches. That's the level of rainfall which is 1 standard deviation below the mean rainfall. And now we want this level of rainfall that's 1 standard deviation above the mean rainfall. So we're adding here, we get 545.2 inches. 545.2 inches is the amount of rainfall that's 1 standard deviation above the mean rainfall. So we just put these two figures into the blanks. The 545.2 goes in here, and this 540.8 goes in the first blank here. And 68% of all years will have rainfall between those two figures. Oops. Trouble stopping this.